Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm here with Kemp Gregory, the CEO and founder of Renewell Energy. Kemp and his team are repurposing idle oil and gas wells for gravity energy storage. We've had other episodes talking about the importance of energy storage on the grid. It helps us manage the intermittent supply of renewable energy from sources like wind and solar. Energy storage also helps better utilize the existing capacity of the grid. Without storage, we need a grid that can supply enough energy to meet the highest demand peaks, which means that today in the US, we average only about 33% utilization of the grid's potential capacity. Rather than use batteries, Kemp's approach is to repurpose existing unused infrastructure. His system raises and lowers weights inside oil wells to store and deploy energy. To introduce Kemp quickly, he grew up in Texas, where he got his first degree in mechanical engineering. He then worked for Shell for 5 years as a completions engineer, which I had to look up, but it means he was involved in optimizing well design for oil and gas extraction. He left Shell and got a master's degree in energy engineering from Stanford and co-founded Renewell in 2019. According to his bio, he's also an avid ping pong player. Kemp, it's a pleasure to have you.
All true statements.
All true. All right. Let's talk about that origin story, because one thing you told me when we first met is that you first grew up wanting to work on cars. I think you said your dad ran auto body shops or automotive repair shops. How'd you end up in the energy sector?
Yeah, a lot of times you meet people and they're like, oh, I'm third generation oil and gas. And even though I grew up in Houston, there's like none of it in the family tree. So yeah, my dad had a small business, automotive repair shops. I spent my summers more or less as like a sidekick to mechanics, running and getting parts and flushing transmissions and stuff like that. And I thought cars were just the coolest thing on the world. And I wanted to go work for GM or Ford or whatever. And so my journey to the oil and gas world can best be described through my internships in undergrad. So I got an internship with Ford in Detroit, and I was like, the first 6 weeks, I was like walking on clouds. This is the coolest thing ever. I can't believe I'm here. And then the second 6 weeks, I just had a bad experience in Detroit, and realized that I didn't really want to live there anytime soon. It wasn't for me. And so I was like, okay, well, I got to think of something else to do, because there goes that life dream. And so I also had all the wisdom of a 20-year-old, so have some mercy on me. So I was like, I'll do wind energy. That was a bustling thing in Texas at the time. So I got a wind energy internship, but this was with Shell. And this is sort of the beginning of how I got into the oil and gas world. First 6 weeks, same thing. I was like, this is so cool. I'm learning so much about the electric grid. This is it. This is what I want to do. And then the second 6 weeks, I just realized that Shell didn't really care that much about wind energy. And it was sort of a side project. And I was like, well, I want to be where all the money is being spent. Like, I want to be where the business is actually doing its business. And in 2011, that was shales. That was hydraulic fracturing. That was horizontal drilling. I basically pitched my Shell overlords like, hey, I don't want to do wind energy. If I come back, I want to do this other thing. And they're like, okay, cool. So that's how I got into it. It was sort of happenstance. I didn't like research it a ton. I thought to myself like, hey, I just want to be where the business is actually doing its primary function. Fast forward 5 years, I'm living in Argentina. I've been working for Shell the whole time. I've traveled the world, and I've learned a lot. Hopefully wisdom was appreciably higher by age 26 than 20. And I just started to realize that the grand engineering challenge of my generation, our generation, is going to be overhauling the electric grid. It's not going to be figuring out how to put gasoline in cars. We pretty much nailed that one. We got it. It's going to be figuring out how to go from on-demand dirty to off-demand clean, but ultimately on-demand clean for every electron everywhere. And to me, I was like, that is an insane goal. I want to go work on that. That seems like a huge challenge. I had a front row seat to realizing that like, there's not a lot of reservoirs left. There's not a lot of tricks left in the oil and gas bag. Like hydraulic fracturing and horizontal drilling is super creative. I was proud to work on that technology and in that space. But I mean, you're breaking up the kitchen to get food, right? You're not even in the dining room anymore. The dining room would be like you're drilling a reservoir that flows on its own. Now you're ransacking the kitchen to get food. Like, where do you go after that? There's nowhere to go.
Like, we'll just run out of oil.
Or we'll just keep ransacking more kitchens. But you can't go any deeper. We're already at the deepest stuff. You can't go any easier. We've already gotten all the easy stuff. Just for those who don't get the analogy, ransacking the kitchen is hydraulic fracturing. Like, you're breaking things. You're breaking up the rock. You're creating man-made permeability where there was hopefully a decent amount of porosity to extract what didn't want to come on its own.
What's the downside of that?
You could keep doing it. You could keep doing it for a long time. But I wanted a world in which there was going to be challenge and opportunity. And even though I jumped into what was something that was revolutionizing the oil and gas industry, like even in the 5 years that I was there, they more or less got it down. There wasn't a lot of more challenge or opportunity to be had. So in my calculus, I'm thinking challenge and opportunity are directly related. I want to go where there's challenge so that there's opportunity. And as soon as I learned about the electricity side of things, I was like, that is a huge challenge. Therefore, there's going to be big opportunity. That's where I want to go. Yeah. So it's not necessarily like the bleeding earth narrative. Sorry in advance for anybody who's like offended by that. It was really just like the fascination of a massive challenge.
And when you saw that challenge, was energy storage, when did energy storage specifically come into focus for you?
Yeah, that was only after I spent some time at Stanford when the revelation happened that, hey, we could build all the wind and solar we want, but the grid will never run on 24/7 clean power without a lot of energy storage helping it out. That realization of like, oh man, the next wave of build out is on the energy storage side. There's a lot of work left to be done on wind and solar, don't get me wrong, but like the core components of what a wind turbine is and what a solar panel is have basically been done. It's just making them cheap and then deploying them at huge scale, assuming fusion doesn't come in and wreck everything. Wreck everything for me.
Yeah, I mean, could be a good thing.
It'd be good for the whole world, no doubt. That's not even that true, which we can get into a little bit more later. But fusion wrecking my world, I mean. But yeah, it was Stanford that really helped me understand, like, whoa, without energy storage, this is just not going to work. The accusation of renewable energy being intermittent is a fact. It's just, you can't control when the wind blows and the sun shines. And I like to say it as civilization's demand curve and Mother Nature's supply curve. They don't line up and neither side's willing to budge. You have to have energy storage to make that work.
And one thing, I said this in my intro too, but one thing that I hadn't really realized, and tell me if I have this right, but it feels like even with a base load or a constant supply of renewable energy, we still have a fluctuating demand depending on temperatures and time of day people come and go and stuff. So with that scenario, we still have to kind of overbuild the grid, overbuild our generation capacity to meet those peaks in demand, unless we have energy storage. Is that one thing driving the need for energy storage? Is that accurate?
Absolutely. Right. So if you think about there's two options in your head, visualize a graph that's energy on the y-axis and time on the x-axis. And demand at any given place looks like one little bump in the morning and a little dip and then a big bump in the evening and then it goes down. You could drown that sequence of bumps in wind and solar, but you would have done the world a huge disservice, in my opinion, because you spent way more money than you should have to get the effect you need. What you should have done is build just enough area under the curve. It's going back to some old school calculus here, just enough area under the curve that you could shift it around to match what the demand curve looks like. And that is a much lower cost, more logical solution.
A lot of people look at that problem and have been investing in electrochemical batteries. We've had pumped storage hydro for a while. I'm curious what led you to gravity storage in this way, and how'd you come up with this?
So we started looking at all these idle wells, which is not a very well-known corner of like the environmental world until recently. Like when we started in 2019, advisors would send us an article a quarter saying like, hey, look, someone's talking about idle wells. And then 2 years later, it was like, we couldn't even keep up with the number of people that were sending us articles about idle wells. It became very in vogue. But even then, they were actually mostly talking about orphan wells. So one quick little note of context here. The oil and gas industry, in terms of wells, can be broken up into 3 layers. And I'm just talking the United States. There's about 3 million or so active wells. They're making oil or gas or both. There's about 2 million idle wells. They're still owned by someone, but they don't make anything at all. They just sit there and do nothing. And then there's, depending on who you ask, 200,000 to 1 million orphan wells. And so the great threat here is that this top funnel is going to go into the middle funnel, and the middle funnel is going to go into the bottom funnel, and you're going to get this ballooning of orphan wells. We looked at that problem. We said, how can we help? How can we fix that problem? Truthfully, that was the first problem we started with.
Before even looking at energy storage?
Before looking at energy storage.
Oh, okay.
And it was like, weights in wells. You can make energy. Like we knew that the crux of the clean energy world was energy storage. And we knew something had to be done about all these idle wells. And it was those two put together that we were like, those two problems, which most people would not connect at all, could actually help each other a lot. And so presto, you got what was originally called Gravity Well. And then we renamed it to Renewell.
And why are idle wells a problem? Why is that something you need to fix?
Oh, man. First off, like I said, there's millions of them. Second off, a lot of them are in urban environments. So think of like Dallas, Houston, LA, Denver, a lot of these big cities, San Antonio. A lot of these big cities have wells inside of them. LA is the largest urban oil and gas field in the world, or in the United States. I can't speak for the whole world. But yeah, so sometimes you got like house, pump jack, house. And for a pump jack that's not operating, even a pump jack that is operating, that's not good. You shouldn't have people living next to pump jacks. And not only can they like just conventionally spill hydrocarbons, but they're also connected to like higher levels of benzene, higher levels of PM 2.5, just bad stuff coming out of the wells. Bad stuff for humans. In Bakersfield, where I live, I see it all the time. It's orchard, pump jack, orchard. Doesn't seem like those should be around each other either. We should be separating them out. There's the sort of chemical component to having idle wells in abundance. Then there's just the fact that they're an eyesore, like that. We're just going to leave them like that for forever. The answer is like, no way. That's sort of morally unconscionable. We got to clean them up.
I imagine one solution you would look at is kind of capping them, sealing them in a way that they're not going to emit, filling them in so you can build or plant around them or whatever.
Yeah, that process is called plug and abandonment. And about $2 billion gets spent on plugging and abandoning about 25,000 wells every year. That's US. But at 2.5 million, that math actually works out real simple. It's over 100 years to do all that work. And it's way too much money. It's hundreds of billions of dollars. And there was this awesome report that came out, I think last year, by a friend, a guy named Dwayne Purvis, who basically said the price tag to clean up all the wells in California is circa $13 billion. The projected revenue for the industry is $6 billion. That leaves like all domestic oil and gas production in California is projected to create $6 billion in its future. So even if they redirected every last dime to plug and abandonment, they still couldn't afford all these wells. So we are careening towards that disaster scenario where I described a lot of idle wells becoming orphan wells. And now it's a taxpayer problem. And this taste we've had of having to spend money on orphan wells is going to go from a taste to a heaping pile of problem. And I don't want that to happen. I'm a taxpayer in California. I don't want to pay taxes for that. I don't want the rest of the United States and or the world to bear the burden that was created by the oil and gas companies. To all of our mutual benefit. Hydrocarbons are an amazing thing for a long time. They still are pretty amazing. They make our lives pretty great, but we got to clean up that mess. And right now we're not equipped to do it. Not on the government side, because that would be political suicide to throw that much money at the problem. And not on the oil and gas industry side. They just haven't saved enough money.
So you're making it financially beneficial to clean up those wells.
We're a money-saving enterprise from the oil and gas company's perspective. We want to come in and say, you don't have a lot of great options for managing these idle wells. We want to give you a new good one, wherein the well still gets sealed above its shallowest perforation, so it can't leak methane or any problematic substance. Plus, we'll monitor it in the event that it does and go fix it right away. Because in an ideal world, you would plug and monitor wells. You would not plug and abandon wells. So that's more or less what we do. But then we get to add the energy storage on top. And it's kind of like a way, I like to think of it, this is probably too romantic, of like an olive branch to the oil and gas companies. Like, hey, join the energy transition in a way that you understand and helps you. Like, don't whitewash it or greenwash it or whatever color. Do it in a way that really matters. Solve a big problem, save some money. Welcome to the team,
Okay, so they still own these idle wells. This gives them a way to plug them, monitor them, and make money on that and pay off that investment by selling energy storage services.
Well, yeah, so there's a couple business models available, but the one we go with is that we own the surface equipment and Renewell receives all the energy storage revenues. What's in it for them is that cost savings upfront. We live off the energy storage revenue.
Do you get any pushback from the kind of climate investing community or climate community for being working with oil and gas companies?
Every once in a while, I'll get a VC that's just like, no, this is too oil and gas adjacent, or no, you're helping an oil and gas company, therefore we can't work with you. I would say that's the minority by a pretty large degree, which is nice. Most of the VC community, I think, well, they want to make money, but also they get that rebuilding everything from scratch is a crazy town notion. It's just not going to work. That the United States has like hundreds of thousands of miles of oil pipelines and natural gas pipelines and roads and electrical infrastructure. Like, we should be repurposing as much as we possibly can. That's where we should start. In an ideal world, you not only repurpose that infrastructure, you get paid to repurpose the infrastructure. That's what Renewell is. We create an economic incentive for the oil and gas companies to pay us to convert those wells.
As an energy storage mechanism, how does this compare to electrochemical batteries?
Yeah, so on the metrics that matter to most, it's extremely low capital costs. So I was just looking at NREL's latest predictions for a 6-hour lithium-ion battery by 2050. It comes down to $122 per kilowatt hour. We think that far before then, like in 2030 range, we can get down to $5 per kilowatt hour. So way, way, way less. Yeah. So we're significantly lower cost. Round trip efficiency is one of the other metrics people care about. Lithium-ion batteries, sort of fresh out of the box, they're 91%. But when they've been operating for a little while, they more average 80%. Funny enough, pumped hydro averages about 80% round trip efficiency as well. Our very first prototype was 70%. We could probably get it up to 75% and close the gap a little bit. But we're pretty comfortable with the 70 to 75 range. We're basically betting that at the end of the day, price will matter more than round trip efficiency. But the real energy storage nerdery happens when you start talking about multiple gravity wells together. And this is where things get really fun. In the energy storage world today, most companies self-identify by their duration. Oh, we're long duration energy storage. Oh, we're mid duration, short duration. So, and that generally breaks up to short being 2 to 4, mid being 4 to 10, and long being 10 plus. The beauty of a gravity well situation is that if you have 10 gravity wells, you just stack them. You operate them perfectly sequentially. So this one goes, and this one goes, and that one goes, and da 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 da. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Presto, you get 10 hours of duration. And the beauty is that those same wells could be 1 hour of duration the next day because you just operate them perfectly simultaneously. Even cooler is that they're all doing it at that 70% round trip efficiency. So most of the time when a company says, oh, we're 100 hours or we're 50 hours or we're 20 hours. They're making some massive sacrifice, and it's usually in round trip efficiency. They'll be really low cost, they'll be really long duration, but the round trip efficiency will be garbage. Our systems, we don't have to make that trade-off. We could have 100 wells do 100 hours at 70%, or 100 wells do 1 hour at 70%. The wells have no idea. They're just being commanded to do a thing. And so that's one of the really fun aspects of what we can do. And then the other one is, like I said, energy storage companies sort of self-identify in these sort of arbitrary and discrete durations, 2, 4, 6, 8, 10, as if the grid is going to magically need those arbitrary and discrete durations, when in fact it will not. It's going to be 9.7 and 3.6 and 98.2. It's going to be totally random. I mean, it's not going to be totally random. It's going to be dependent on the weather of what duration is critical. And we can do any duration. That same 100 wells, you could order it to do 50 hours. You could order it to do 59.6, 22.7. You get the idea.
It's just infinitely adjustable.
Yeah, it's the most flexible energy storage that I can think of, that I can think is possible, is what I mean.
Because of that ability to kind of work multiple wells in concert with each other, either in parallel or in series. Yeah.
Yeah.
And you just have some kind of smart system to do the controls to deliver what's needed.
And if you asked electrochemistry to do the same, one, they're so high cost that they wouldn't do that for economic reasons. They wouldn't be able to take a charge, hold it for that long, and then give it back and still make money. But they have self-discharge. It's like asking something to hold energy and it's got holes in it. It's like asking a water tank to hold water when there's holes in it. That's electrochemistry. For us, not the case. We bring the weight to the surface. We put a big mechanical clamp on it. We could hold it for 2 days or 10 months. It wouldn't make a difference. I'm not going to lose an ounce of energy.
And people talk about batteries. One advantage of electrochemical batteries being they're kind of geography agnostic. They can be put anywhere. What are the pros and cons of being tied to where the wells currently are today?
Yeah, that's definitely a pro in the electrochemistry column. A con that we can't control where the wells are. This is where I typically like to show people a map of all the wells in the United States. They're in a lot of places. We just don't see them very much. They're in a lot of places. Now, are those the right places? The grid is one massive machine, and electrons move pretty fast. So connecting to the grid in one place and connecting to the grid in another place, considering line losses, it's really not that big of a deal. But most of the time people say like, well, these wells don't have any electrical infrastructure. What are you talking about? And the short answer there is like, yeah, they do. Most wells are electrified because the oil and gas companies have paid an arm and a leg to build out an enormous amount of electrical infrastructure to bring electricity to pump jacks and electric submersible pumps and all the other crazy methodologies they use that are really energy intensive to get oil out of the ground. So, but it's just one of our criteria. We basically won't go into a well unless it's already electrified. Then the other people say is like, okay, you've convinced me that there's electrical infrastructure, but where's the demand? Like you're out in the middle of nowhere. And the short answer there is, let's say my argument about the grid not moving electrons around effectively is squashed for some reason. The oil field itself is a massive demand center. Like West Texas is going to grow gigawatts worth of consumption over the next 10 years because they're expecting so much more infrastructure, so many more wells to be drilled. So there's a huge amount of electrical demand in these oil fields. So if we're just constrained to that demand, then the argument would be we're more or less decarbonizing oil and gas extraction, which I guess is a slightly less moral high ground. I mean, the oil's going to get used. Would you rather coal power do it, or would you rather wind and solar do it? Or would you rather those wells sit there forever? So it's like the wells sit there forever and it's all dirty power, or the wells get cleaned up and it's clean power.
What does your system look like? What's the hardware?
Yeah, it's 3 components. Fortunately, it's an alliteration, so I can never forget it. It's a weight, winch, and wire. So the weight in the well is just a long, skinny tube, but it's ultimately oil field casing. So we are committed from top to bottom to this whole repurposement idea. So we didn't go out and design some new weight. We just bought oil field casing at scrap price and filled it full of really heavy drilling mud. So don't think like earth mixed with water. It's like a scientific concoction, more or less. So we put this tube in the well, we filled it full of really heavy drilling mud, not its original purpose, obviously, but it serves as a good use here. And then we connected a big wire rope to that weight. And then we feed a wire rope up through a sheave and then over into a big regenerative winch.
I read, or maybe you told me, we're talking about a 30,000 pound weight.
Yeah, our commercial installation in California Central Valley is a 30,000 pound weight. So quick history of Renewell here. In 2020, we had nothing. We've just gotten the company up. By 2022, we'd already built a prototype that could lift a 3,000 pound weight and put it in 2 wells, one in Texas and one in California. Same prototype, we just picked it up and moved it because we built it in Texas. We wanted to trial it somewhere nearby, but we've always known that California is our beachhead market. So that's why we picked it up and moved it. And now in the year and a half from that first prototype, we've graduated 10x to a 30,000 pounder. So I like to say that by hardware standards, we're moving at like lightning speed. And that's due a lot because 1, our engineering team is brilliant. And 2, it's a lot of off-the-shelf components. We're just putting them together. When I hear people who are very zealous for climate action talk about how fast we need to move, I sort of chime in with like well, not only should we repurpose, but we should be using things that don't have to be invented in a lab to make it happen. So we try to live that pretty truthfully, we just go out and get regular parts and put them together in this whole new way.
Was it always obvious how you were going to create that weight? I know I've heard in other industries, like finding a way to create weight cheap, economically is not always an easy thing. I imagine those are some fun brainstorms. And actually, just to put it in perspective, I was like 30,000 pounds, that's roughly the weight of like an unloaded semi truck is what I was looking up.
Yeah, I think that's right.
About 3 elephants. So, this is, pretty big, massive chunk of weight down there.
Yeah, we've gone through a few ideating sessions on what the weight should be, but for the most part, we always knew that it would be casing or tubing from the oil and gas industry. The crazier brainstorming has happened with what are we going to put inside the weight to make it heavier. And drilling mud, just on practicality alone, it's also quite dense as far as fluids go. But we've considered all sorts of crazy things to put inside the weight.
What are some of the engineering challenges? As I mean, you've moved fast. It sounds like a lot of that is thanks to not having to innovate on the kind of components of your system. What has been challenging for your engineering team?
The world of wire rope. One would not expect that it is as deep as it is, but it is extraordinarily deep. By that, I mean, there's more designs than I knew could ever exist for a single thing. There's probably another 10,000 ways you could make wire rope that we haven't. There's just a whole world on how wire rope works. But also the lifetime of wire rope. We're asking it to do things that in some arenas, it's like, oh yeah, no problem. Like mines lift way more weight than what we're talking about. We're like child's play, but they don't do it as frequently and they don't do it as deep. Whereas like a wireline operator in an oil and gas world is like, oh, the depth is no problem. It's your weight that's weird. So we kind of have to like take and choose these different characteristics of the wire rope world that are like, oh, we're really good at that, but we're bad at this, or really good at this and bad at that. And bring them together to sort of get all of the best. So that's been challenging. Specifically, the metric I'm referring to is wire rope life, like how long the wire rope will last. Right now, it's not like a showstopper. Like it's in the 10 to 15 year range, but we want our equipment to last 30 years, and therefore we would like the wire rope to last 30 years. So there's all sorts of creative ways you can go about doing that, not just necessarily some newfangled wire rope design. That's been one of the bigger challenges is wire rope.
I imagine you could replace the rope and still reuse a lot of the other equipment.
Totally. Yeah. You could very easily bring the weight to surface, clamp it off, hang it out the wellhead, take the rope socket off, remove all the wire rope, redo the rope socket, spool it back on, and you'll be back in business in a day. It's more the cost. It's the cost of a whole new wire rope.
How much is a wire rope that we're talking about? How much does this cost?
Thousands of dollars. Like think of something in the range of like $15,000 to $40,000.
Can you give us a sense of scale? Is it, diameter and how long are we talking?
It's about an inch, and the wire rope that we have on the well right now, I think, is about 3,000 feet long.
And what is the failure mode? Does it creep, and does the length change over time? Does it fatigue and break?
It stretches a little bit. Stretch is not our main worry. It's the abrasion of the wire rope against itself. So when you wrap it up on the drum, it's going to be abrading against itself. It's also going to be coming up against the casing walls inside the well. So it's just abrasion. It's how much those individual strands, which there are dozens for any wire rope, can take the beating and still be at their fully rated strength.
Is there anything as an engineer or technically about your system that still keeps you up at night? What are the big kind of risks on the horizon?
And nut we haven't attempted to crack yet is the remote and collective control of multiple systems. This whole thing I'm talking about of like, if you have 100 gravity wells and you could operate them 100 hours or 1 hour, in theory, it's very doable. And with sort of the state of the Internet of Things and remote control devices, I don't think it'll be an issue. But like I said, we just haven't gotten there yet. We haven't built a whole bunch of these yet. So in the same way that I draw deep comfort from a weight, winch, and a wire being relatively simple execution, simple technology, I draw comfort from the fact that like remote controlling wells to operate in series or sequence, there's no reason that shouldn't work. We just haven't done it yet. We need more money to go build more systems and prove that that portion can work as well. That feature can work as well.
On that kind of scaling topic, where are you in the process? You have one full-size commercial well in operation in California, it sounds like.
Yeah. And that was part of a $2.7 million grant that we got from ARPA-E in collaboration with the National Renewable Energy Laboratory, or NREL, which has been a wonderful partnership. We've really enjoyed working with them. Inside the 2.7 million was to build our first commercial device, this one we're talking about, Alpha, which I know is not a very creative name. You will never guess what the second one's going to be called. The second one should be up and running in Q1 or Q2 of next year. And that one we're going to call Beta. The mission right now is to go out and raise our Series A and get investors on board, and then build the team and build another 5 or 6 systems so that we can get to that remote and collective control. Hey, proof that by that time, we'd be at, circa 8 systems total. And we could say like, yeah, we can do 8 hours of duration. We can do 1 hour of duration. We can do anything in between. And then a Series B that would be mixed equity and debt, because like I said, it's a lot of off-the-shelf equipment. So we can leverage that fact and not have to equity source everything.
Are there regulatory hurdles?
So like I said, focused on California. And so we are in the process of running a bill. We talked to the regulator many, many, many times, and they ultimately told us, you need to run a bill. So we sort of walked away thinking, dang, that's going to be hard. We hired a director of government relations, a woman named Evan Taranta. She's brilliant. She's been spearheading all of that work. And now we've got a bill. It's through the Senate and into the Assembly, and it's looking really, really good. It's been pretty smooth sailing. Like the votes as we go through each committee are overwhelmingly. Yeah, I'm really excited about what that will unlock come August 31st, should we make it all the way through, of which I'm quite bullish that we will.
I saw on LinkedIn a video of you testifying in front of the California Senate Natural Resources and Water Committee about passing this bill, I guess.
That was step number 1. The things I never saw coming 10 years ago, that's probably like top 3. I never imagined that would be something I would get to do. But it was really cool. Just sort of the history nerd in me is sort of adjacent to the political nerd in me. And just to watch how the government works in a tiny little microcosm as bills before us were debated and stuff, I was like, this is neat. I'm proud to be involved in this process.
Can you say a little more about the bill? What's the title and how is it defined?
Yeah, it's called SB 1433. And it effectively creates a landing space for idle wells that have been converted into gravity wells. In a highly regulated industry like the oil and gas world, you need titles for any new thing. And that's totally appropriate. That makes a ton of sense. We wanted to take the high road and create a structure for the state to recognize idle wells that have been converted into gravity wells. In the shortest description I can give, that's effectively what it does.
What's your vision for the future of Renewell?
So we estimate that about 30% of wells will be suitable for conversion. That comes out to, hundreds of thousands, 700,000 based off of today's current idle well count. That's not even accounting for all the active wells that will go inactive over the coming decades. We think of orphan wells as a really great opportunity to repurpose something that was headed to its death. But often orphan wells won't necessarily be the greatest fit. They're orphan for a reason. They've been mistreated. They're probably not in very good shape. So the final vision would be hundreds of thousands of wells converted into gravity-based energy storage. Repurpose the electrical infrastructure that's in the oil field. We repurpose the wells. Maybe some of those fields have shut down completely and now they're just big mechanical batteries. That would be a pretty awesome world to have helped build, where people don't think of oil fields as oil fields. They think of them as like rural mechanical batteries. That would be pretty awesome. Yeah, in between now and then, I want to build the team. I want to build the business. I want to get more customers. And we're shooting for like 1,000 wells in like the next 4 or 5 years, which would still be a pretty big undertaking, probably be in California.
And that kind of grand vision of the 30% or so, how meaningful is that, or in the context of the total energy storage we need in the US? Is
that final vision, hundreds of thousands of wells, circa 700, would be 132 gigawatt hours worth of energy storage, which, depending on who you ask, would be somewhere between like 5 and 10% of what the total amount of energy storage needed for the nation is. So it's not like a single point solution. This is not enough energy storage to solve the problem in and of itself, but it's not going to be like 0.001%.
Oh, it's a big chunk. You piqued my interest earlier when you said that if fusion does come online, it actually isn't bad for your company or bad for you.
The main reason there is that we have to clean up these wells. We have to. I mean, not only is it law, but like I said, it's sort of morally unconscionable to just leave them there. And so what better thing to do with them than to turn them into energy storage? Even if you had a bunch of really low cost on-demand energy supply, the need to store it, I still think would be prudent, for the same reason that we ought to have energy storage even without wind and solar. Like if a plant goes down, you ought to have backup. And right now we back up our fossil fuel plants with more fossil fuel plants. We should back up our fusion reactors in the future with more energy storage.
Yeah, and I think back to that point that even if our supply is constant, our demand is very unlikely to be constant. So to
Right.
be able to meet that demand with less infrastructure seems to be a good reason to have storage.
There's also this burgeoning issue, which is very electrical engineering heavy, and I'm not an electrical engineer, so I don't want to lie. But as far as I understand it, resources that can respond quickly to the grid are becoming fewer and fewer as we add on more wind and solar. Not only can we not control them, but we can't get them to act fast. That's what electrical engineers refer to as inertia. And so the grid has like a plummeting amount of fast acting, responsive energy supplies. We used to just fire a peaker plant and it would send electrons onto the grid and balance things out, balance the frequency. But if the frequency gets too high, if the frequency gets too low, in the high scenario, you start burning things like motors and people's, fridges. And it gets too low, then the light bulb just flickers and goes out. So the need for fast acting energy storage is apparent, regardless of the source. Yeah, like the UK grid almost collapsed last year or something like that because it didn't have enough inertia because it was so wind heavy.
Okay, I have 3 last questions for you. The first we kind of touched on at the beginning, but I ask everybody these same 3 questions. So the first is, how optimistic or pessimistic are you about the future of the planet and why?
Quite optimistic. I think that human ingenuity usually rises to the challenge. I mean, it needs to be set inside of logical political structures. Otherwise, human innovation has no chance to thrive. But as long as we can maintain sort of our political stability in as much as we have it now, then yeah, I think human innovation, especially American innovation, will win the day.
Who is another company or individual doing something to address climate change that's inspiring you?
Oh man, I don't know his name off the top of my head. I can look it up though. But there's this Stanford startup called SkyCool, and they have this material that they can as far as I understand it, paint onto the surface of a roof or any surface for that matter. And it changes the nature of the radiation from the sun bouncing back. I mean, because that's the whole issue with global warming, right? This quantity of CO2 in the atmosphere has a very narrow band of radiation that it wants to trap and heat our planet with. And if you can just shift the radiation outside of that narrow band, then it'll just bypass the CO2 and go right back into space. And that is an awesome solution. That's like one regulation away from being a $1 trillion company or $1 billion company. I should remember that guy's name, but that's a brilliant idea.
It looks like maybe Eli Goldstein and Oswald.
Yeah, that sounds right.
What advice do you have for someone not working in climate today who wants to do something to help?
I probably sound too much like a VC, but I would say find a problem. Climate change is not a problem. I mean, climate change is not a specific enough problem to start a business on. I've been told by so many VCs, like, if you come to me and tell me your problem is climate change, then I'm just going to tune you out. So you just need a more specific problem. Find some niche that you really understand where there's a mega problem and you can solve it. Start with the problem.
It sounds like you've done that really well. Kemp, that was awesome. Really big fan of what you're doing. Thanks a lot for your time.
Yeah, I'm glad we finally got this done.
Yeah.
Sorry for the technical issues that impeded us in the past.
No, it was a pleasure. Thank you. Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.